Hi, and welcome to the Chorus One podcast. This week we're joined
Welcome
by
to the Chorus
Brad
One
and Emre
podcast.
from
In this
O1
podcast,
Labs,
we explore the emerging
working on
open
the Coda
financial
protocol.
system.
Welcome,
We
guys.
dive into
Thanks.
scalability,
Yeah.
interoperability, proof of
So
stake,
why don't we
blockchains, and
just
many
start
other
with
parts
some
of this
introductions
coming
of
financial
yourselves?
singularity.
Maybe Brad, do you want to go
Tune in
first?
every
Sure.
Monday
Yeah,
to
so I'm
dive
head of
deep
strategy and
into these
operations
cutting-edge
at O1
projects
Labs.
and protocols
I head up
with
business
Chorus
development.
One team members and
So that's the
guests.
second one was Emre. I don't know. Maybe no one mentioned it. And I guess what's always interesting for most of people to hear is just how did you end up in this space? Like, what was your background? How did you end up at Coda working on this blockchain technology?
Sure. Yeah, just briefly. The first time I was introduced to actually using Bitcoin for anything, I was an intern, high-frequency trading firm, and all the interns were obsessed with playing poker online. And the only way you could actually play poker at that point was by buying Bitcoin. So that's when I first actually used Bitcoin. I got into the industry because Isaac was a friend of mine. He was studying cryptography. At Berkeley, we had worked together on some side projects in New York. He was at Jane Street, the trading firm at the time. I was at Bridgewater, which is a big hedge fund. And so, yeah, as he was sort of ramping up the project, he called me up one day and he's like, oh, it seems like you're somebody who might know a little bit about monetary policy since, Bridgewater is a big macro hedge fund that focuses on monetary policy. How would you design a monetary policy for a cryptocurrency? So I thought that was a very interesting question. And we talked about it a little bit more and just seemed like a really fertile ground that I might be able to contribute a little to. So I flew out to San Francisco, basically spent a weekend working with Evan and Isaac, and by the end was so excited that I quit my job and moved across the country.
Yeah, on my end, so I'm a more recent joiner to the team over here. It's been about 7 months, but rather longer in the crypto space. I guess my first entry was from two different perspectives. One of them was more personal in that, so I originally sailed from Turkey. That's my hometown. I moved to the US about 6-7 years ago, and if you spend most of your time in the same country, the financial infrastructure is well designed to serve your needs. But the minute you start crossing borders, you run into a lot of issues. So that was the first time I very personally started experiencing how antiquated our financial infrastructure is. So that left a mark on me. And then from a more professional angle, during my earlier career, I used to work at Intel. At one point, I was PMing a payments product where you get to see how many different intermediaries and steps there are required to process a simple credit card transaction. So that got me thinking, oh my God, this is so inefficient. Is there not a better way? That also overlapped by the time I was going to start grad school. So I kind of had, of course, heard of Bitcoin, but started looking deeper into it. Ended up spending some time at Ripple with the biz dev team there. And then after grad school, I ended up joining Coinbase back in 2017. When it was about 100 people, then everyone suddenly started talking about Bitcoin and Ethereum again. That's when the price started going up, obviously. So I ended up, doing a bunch of different things at Coinbase during a time of hypergrowth, including launching their custody business as well as leading USDC for about a year. After which, I started looking at, okay, we have a great platform here as a space in the industry, but we need to kind of take it to the next chapter. And that's when I came across Coda. And the team's approach blew me away, so that's why I decided to take a leap of faith.
Okay, it sounds like you're quite a veteran in the blockchain industry, definitely. And it's interesting that you specifically chose Coda, and I hope we'll find out in this episode why that is the case. So maybe why don't we start there and get a little bit of a high-level overview of what Coda is and what it aims to solve.
Yeah, certainly. That's a good segue indeed. So when you look at blockchains in general, we think there is or has been to date a bit of a design issue with how we design these machines. So obviously Bitcoin, Ethereum, and some of the other projects, they're revolutionary, right? That's why we're all here. And kudos to all the creators that came up with this innovative concept. But when you dig deep, what is a blockchain? A blockchain is what we call a trust machine, and others have done this as well, which essentially enables many different types of people or institutions to trust each other or trust a series of computations without having to go through an intermediary. So it's a new type of a machine, and we think the industry has been in a bit of a weird spot thinking about them as computers. Ethereum dubbed itself the world computer, which is true. It's a bunch of computers connected together, but in its entirety, it's not a computation machine. In fact, it's a very bad computation machine, right? Bitcoin, Ethereum, and most of the other large ones infamously do a limited number of transactions per second or computations per second. And so, and the reason for this is because anyone that wants to access this machine has to redo all of the computations from its genesis, right? So if you want to run a full Bitcoin node, which is the only way to trustlessly access a Bitcoin blockchain, you need to download 300 gigabytes of data, rerun all the computations, and get to the present time and space and state. So how can we overcome this issue? And that's when I came across Coda, and was like kind of blown away in that this was the only approach to my mind that made sense. And it mostly comes from its use of zero-knowledge proofs. So what is a zero-knowledge proof? I won't do it quite the justice, but at the highest level, I think it's a computation, and this can be any computation, whereby as you do the computation, you produce a proof which enables anyone to easily and cheaply verify that that computation was done correctly. And Coda came up with an innovative way to apply this to the design of a blockchain, in that the entire blockchain always has a fixed size proof, which is in the order of a couple of kilobytes, which enables anyone to essentially run the equivalent of a full node without having to download 300 gigabytes, 1 terabyte of data and redo all of the computations. So this enables two things. One of them is that it can be way more decentralized, because again, everyone essentially is a full node, whether you're connected from your $2,000 desktop or a $100 smartphone or feature phone. And more importantly, it resolves this phenomenon known as the scalability trilemma in the industry, in that you cannot be scalable, decentralized, and secure at the same time. You need to pick at most 2 of the 3. Why has this been an issue? Because as we discussed, the larger a blockchain is, which usually means either the longer it's run or the more throughput it has, the larger it gets, leading to less nodes being able to connect to the network. But if you fix the size of the blockchain, it no longer matters how long it's been running for or how much throughput it has, right? It stops becoming a scientific or a theoretical issue or an economic one. It starts becoming an engineering problem, which is something that can be solved. It becomes more about how can you jam more transactions through a peer-to-peer network, which is still a considerable challenge, and it's something that we're dealing with in our testnet. But the good news is it's an engineering challenge, and as we know, these things get better over time. Yeah, so that's, I think, a high-level overview of why Coda is so revolutionary, and we can dig into any of the use case-related stuff later on.
What's quite interesting is that on the Coda website, it states that people will be able to run full nodes via their browser and boot transactions from their browser while having the full security of a full node. But as revolutionary to me appears the ability for a different blockchain to be a full node of Coda. So one could conceivably imagine Ethereum running a Coda full node with very little cost.
Yeah, I mean, that's actually a really interesting point, and maybe something that we haven't explored as much as we should, but I think that's really interesting. I mean, I think gas cost to verify a zk-SNARK on Ethereum is actually still pretty reasonable. So if you had an application where you wanted to do that, I think that certainly wouldn't be out of the realm of engineering possibility. And we also think about Coda not just as a cryptocurrency, but also as a platform for developing zk-SNARKs. I think we've done a lot of really awesome work collaborating with a lot of groups in the space to push the boundaries of what's possible with zk-SNARKs, both on the construction side and also the engineering side, but also just showing that zk-SNARKs are sort of an incredibly important cryptographic primitive that are going to take the industry to the next level. Because if blockchains are trust machines, what's better than not having, what's better than making sure that everyone can sort of trust something with a tiny amount of computation, regardless of transaction throughput, versus having to redo everything themselves. So we think this is sort of like a huge leap in terms of what's possible to do in these decentralized, trustless environments.
And I'd also add, this expands the realm of possibilities, right? That's what crypto's about at the end of the day. It's about permissionless innovation and value and all of that. But I think one thing over the years that we've seen, or at least I personally have seen, is there's so many theories and possibilities of what can happen, right? These Lego bricks of different blockchains and cryptocurrencies. But we're so early. Like none of this stuff works, like right out of the box. There's going to be so many UX issues, so many complexities, technical and otherwise, that our approach, like not only is Coda, in my mind at least, revolutionary from a technical angle, but also revolutionary in approaching things in the simplest way possible. In that, how can we get people to interact with a blockchain with only a couple lines of code? So that's one of the two main use case angles that we have in mind, is kind of like to be a Stripe of crypto, in that, what made Stripe successful was not because there were no other payment processes before it, but because it made it a 10x, if not more, easier for developers to start accepting payments and testing their applications on it. In a similar way, with Coda, you can do that for blockchains and crypto without having to run a full node or sign up for Infura or have to learn Solidity and all of this stuff, right? So yes, there's so many possibilities with Coda and zero-knowledge proofs in general, but we think what's going to get the most traction is going to be the simplest thing at first, and that's why we focus the efforts on building the simplest blockchain that we can.
Okay, that's interesting. Maybe you want to expand a bit on this in this part. You're saying Stripe for crypto. Do you want to go a bit into like the go-to-market for Coda, or what do you see as like the first things that Coda will be best suited for?
Yeah, certainly. So if you don't mind, I'll start from the other use case that we likely will kick things off with, which is permissionless cash or permissionless money, right? And this goes back to a problem I alluded with existing, monies in crypto land. So Bitcoin, for example, has, fair and square won the digital gold space, which is amazing. But there's two problems with it. One of them is that it's not permissionless. It's easy to trustlessly access this. And permissionlessness enables so much more innovation and experimentation. And then the second thing is it's gold. People do not want to spend gold. It's a store of value asset, right? So if you look at the definition of a money, it's both a store of value and a medium of exchange. So we see Coda as what we call hard money, in that it's both sound in its store of value properties, as well as in time it's going to get better at being a medium of exchange of an economy, which we think will be the internet economy, because currently developers that have issues with integrating payment systems, existing ones, or cryptocurrencies such as Bitcoin or Ethereum, are going to have a much easier time integrating Coda into their platforms. So we're going to start seeing, and it's going to be small at first, right? We're not expecting like a huge amount of payments to go over Coda in this first year, but over time it's going to go into a rolling ball effect, in that we're going to see more and more of an economy getting formed around both the blockchain and the currency. And we think it's going to stick around because it's more decentralized and more easily accessible than Bitcoin. The second point about Stripe of crypto, again, this is, so many people got excited about the potentials of cryptocurrency, including many of the developers. But many people that got excited about Bitcoin are no longer around, right? There is still a decent amount of development, but there's less about it being accepted as a payments mechanism, or it being, used to develop applications or more innovative forms of economic systems. So we think, those people are still here. They're waiting for something. Maybe they're using XRP or Bitcoin Cash or some of the other ones that claim to solve some of the problems, but they're failing or, doing we think a worse job of being decentralized blockchains. But if Coda is indeed a more decentralized version of a blockchain and can be much more easier to integrate, then we see these people starting to experiment with applications and value transfer over Coda.
And it sounds like you're saying also the payments will happen in Coda, so in the Coda token. There's no, or do you think it will over time become more stable because of all the usage around it, or do you also plan to have some stablecoin on Coda, or what's the idea there?
Yeah, so we are in the launching with support for third-party tokens on Coda, similar to Ethereum or other blockchains. So definitely at first, majority of the payments over Coda that do not involve block production or SNARK work will include these third-party tokens, whether they're stablecoins or something else, because the volatility and money properties of Coda at first will not be great for payments, right? Because it's a new ecosystem that's forming. It's going to have all of its ups and downs. However, over time, to the extent there is decreasing trust in governments and centralized fiat currencies around the world, to the extent there is a larger internet economy, we believe that Coda as a currency can be a major currency in this economy.
I'm really curious about the assertion that Coda can be a hard, quote-unquote, hard money. My impression is that proof-of-stake tokens do not make hard money, and I'll sort of explain why. I'm coming at it from the perspective of cosmos and atoms. So it will be instructive to see how Coda is different in this matter. So the way it works in Cosmos is, let's say I have 100 atoms, and I stake these 100 atoms, and I make 10 atoms a year in interest. The problem is the government's going to collect 4 out of those 10 atoms, and I'm going to be left only with 6 atoms. So because the government always collects taxes, I'm getting diluted every year as an atom stakeholder. So the difference is like this. If I own, let's say I own 100 Bitcoin, and then there's 21 million Bitcoin, I always own a certain percentage of the network supply, right? That's hard. But in proof of stake, when you start with a certain percentage of the network supply, you stake, you earn interest, and the government takes away taxes, you're getting diluted every year. So that's like kind of an invisible inflation you are always dealing with in proof of stake. Mm-hmm. Coda is proof of stake, ergo Coda can't be hard money to me. How do you answer that?
Yeah, that's a really interesting question. I guess there's a few ways to talk about this. One is sort of the invisible security tax you pay with a cryptocurrency like Bitcoin. So there always needs to be a security fee to secure the network. You always need to compensate block producers, basically, for checking transactions. And in Bitcoin, that happens as well. Miners are spending a lot of money to earn those block rewards, and they are securing the network. And that income to them, in the form of block rewards and transaction fees, is also taxed by governments. And so it's not only taxed by governments, but they also have huge fixed and variable costs that they need to pay for. So most professional miners have expenses in fiat that are almost as large as their revenues in Bitcoin. So they are forced sellers in the system. So even though you who hold Bitcoin aren't selling Bitcoin, the amount of Bitcoin that is being sold on the market is still substantial. And that is directly because you have to have some sort of security tax on the network. So whether or not you spend it or another party spends it, those are both things that are contributing to an expansion of the supply of Bitcoin and therefore a pressure on the price. So that's sort of, so you can almost think of these things as like different ways of paying for the security on the system. And then the second thing, and this is sort of in the more developing experimental realm, is there are a lot of different perspectives on tax policy and cryptocurrencies. There was recently a paper that came out of UVA in one of the most prominent tax journals in America by this gentleman named Abe Sutherland that says that staking income, precisely because of what you're saying, because if you don't stake, you will be diluted, it shouldn't be treated as income. Staking reward should actually be treated as more like the way we treat the taxation of created property. So because you are creating the property by participating in the system, it should be not taxed upon receipt, but taxed upon sale with a zero basis. So that would certainly change the tax perspective and the dynamics if that policy was more widely viewed or widely adopted. So tax issues, I think, just generally, and regulation issues with cryptocurrency, these are things that are going to vary from jurisdiction to jurisdiction. And the types of issues of sort of having a security tax and having to secure the blockchain, those are going to be paid for regardless. I think proof of work and proof of stake are somewhat analogous in terms of the effect on the price. And I also don't necessarily think that the current taxation regime that some people are suggesting is going to be global or it's going to be long-lasting.
And just to quickly amplify some of Brad's points, around proof of stake is still super new, right? So some of the taxation issues are always going to evolve. There's a lot of work. In fact, one of the alliances we're a part of, Proof of Stake Alliance, which consists of most of the major proof of stake networks, is doing a lot of great work around this. So I think we're going to see taxation. Again, it depends jurisdiction to jurisdiction, but that's going to be more better aligned with the interests of validators and proof of stake networks. And then also to your point about, like the tax emission, if you will, to Brad's point, proof of work networks, Bitcoin still has that. Like still you're getting diluted because some percentage of Bitcoin is going to the government, who, and we don't know what they're going to do with it, right? So that dilution, I think, exists also in proof of work currencies. It might be more accentuated in proof of stake right now, but there's a lot of work going on there, which in some of the better studies hopefully pointed to becoming closer to proof of work.
Okay, I think we went quite down away from Coda a bit and into some tax policy topics. So maybe we'll just go back and kind of talk a bit more about how Coda actually works and how you achieve this small blockchain, right? So maybe can you talk a bit about the roles in the Coda network and how you can manage to keep the state so small?
Yeah, so the way you keep the state small is a little bit different than the roles in the network, because the roles in the network more have to do with the types of incentives you need to keep all of the parties doing what you expect them to do. So I'll describe maybe first technically how we keep the state small, and then I can transition a little bit into how the different roles in the ecosystem continue to keep the network functioning and operating. So technically the way we keep the state small, or basically this proof small, is we use something called a recursive zero-knowledge proof, or a recursive zk-SNARK. There's a lot of ways to think about this, but one way I like to think about it is by thinking about this recursive nature of a thing. So maybe let's build it up sort of step by step. A zk-SNARK is a cryptographic primitive that allows you to basically get a certificate of a computation. So I do a computation, I produce the certificate and the result. So if I give you the result, I can give you the certificate. You can do a very, very quick computation to check the certificate, and then you can trust the result. And the amazing thing about this is it works for any type of computation, and the certificate stays the same size regardless of how complex the computation was, regardless of how long the computation runs for. This is technically, I'm doing a slight fib there. It's not exactly as complex, but it's pretty close to as complex as, no matter how complex the computation is. Anyway, the certificate remains extremely small, regardless of how long the computation runs for or how much data it takes in. So the process of validating a blockchain is basically, it's a computation, right? So you could say, we are taking in a bunch of transactions. We are checking that the transactions are signed. We are checking that the transactions correspond with valid balance. We are updating all of the consensus information appropriately. And that result can be verified by a SNARK. So that's sort of like one step of it. And you could do this over and over again and basically produce a new SNARK every new block. But if you produced a new SNARK every new block, then you actually have the same type of problem. You are creating something that is growing linearly with the amount of time that's passing, and that's not what we want. So in fact, we do this recursion trick. And one way you can think about the recursion is you take a picture of a picture. So instead of checking the computations as they're coming in, you check two things. You check that the previous blockchain was valid, and that all of the new transactions that come in, and the new block addition, and the new consensus information are also valid. So you're checking a SNARK that certifies that the previous blockchain was valid, and you are checking all of the new information coming in. So it's sort of like this two-step process. You check the SNARK, which is the recursion, and you check the new stuff. So then at each stage, it sort of like collapses in on itself. It's like a picture of a picture of a picture of a picture. But each time, the picture stays the same size, even though it contains all of the information of the previous pictures and sort of certifies them in some way. So that's on the technical side, and I can pause there if y'all want clarification. Okay, so yeah, you're good? Okay.
It's as if, so when the way I'm imagining this is, so the first block came in, so there's some kind of Genesis file.
Yes.
And then the first block came in.
Yep.
And then there's a SNARK that says, that the transactions in the first block are valid given this particular Genesis file, and that's sort of the first SNARK. And then the second block comes in, and then the second block, the input to the second block is the SNARK from the first block and the transactions in the second block. And then you say that if there was a ledger which had this particular SNARK at the end of block 1, and then these set of transactions, then it would generate this current state of the ledger, and here's a certificate.
Yes, exactly.
So that second, that's the SNARK of the second block contains inside it the SNARK of the first block.
Yes.
And then this is going to be the recursion. So the SNARK of the 10th block is going to contain inside it the SNARK of the 9th, which is going to contain inside it the SNARK of the 8th.
Yes.
Contain inside the SNARK of the 7th.
Yes.
And so that is the recursion.
Yeah. A SNARK is like an elephant. A recursive SNARK is like an elephant. It never forgets. So it will always contain sort of the memory of a distant SNARK. And from generation to generation, it will pass down the knowledge that the blockchain is correct.
Yeah, I hadn't heard that one before. I'll use it.
Let's hope they don't go extinct.
That's a Chorus One
special
worldwide premiere of that phrase because I just made it up. So.
It has this fractal nature.
Yeah.
Which
yeah.
You know, like in a tree branches out into branches, there's sub branches out into veins, into sub veins, and sub veins.
Mm-hmm.
It's a bit like your latest SNARK. You can zoom in and you'll find another SNARK inside it, and you will zoom in and find another SNARK inside it.
Yeah. Until
the first SNARK of the system.
Yeah, exactly. And like one thing that we've actually seen bring a lot of people to the project is just the mathematics and the cryptography around the project are just so interesting and so cool. You know, you have new SNARK constructions coming out like almost every month. Like a dozen came out last year, and each of them are massive improvements upon the previous state of the art. And we are really proud to have an incredibly talented team of cryptographers here who are pushing the state of the art forward and collaborating with all the top folks in the field. And you know, it's really exciting to us that we are going to be launching some of the most complex and sophisticated SNARKs on these global cryptocurrency networks that ever been even tried. So it's a very heady time for what we think is going to be a very important general purpose technology.
I'd also add, like, one of the things that make me the most bullish, albeit it's biased, about Coda is this explosion in the zero knowledge proof space. Like, we're gonna publish a poster that includes this graph, but like if you graph out the number of new SNARK constructions since, you know, the past 8 or 9 years, last year in 2019 had as many as all the years before it combined. And these are, you know, like all very advanced work. It almost reminds me, and again, this is a personal bias, but like of you know, the 1970s in the semiconductor era, in that it was the first years of Moore's law, and we're starting to see this hockey stick of new constructions, which both include newer features as well as better proving times and verifying times and smaller proofs. So, you know, we heard from, I forget who now, but like another one of, you know, quality projects in the space, that they looked at their initial design, SNARKs as a potential solution, but then it just was so magical to them, and that it just was, you know, seemed like it wasn't evolving fast enough that they banned any use of SNARKs in their protocol. But I think, you know, kudos to the early team here, to Brad, Izzy, Evans, and others that, you know, they kind of saw the writing in the wall and decided to commit the project to the space, which is indeed growing very fast.
And one more thing on SNARKs is they're also like the semiconductor industry and the internet industry in that in the early days, there were a lot of naysayers that basically said, oh, this can't possibly work. There's so many problems. You know, people said, oh, well, it's not quantum resistant. You have to do trusted setup. All of those problems have been solved. So like trusted setup, there are universal SNARKs now that require no trusted setup. And there are quantum resistant SNARKs that people can choose from. And the way SNARKs are constructed now is this very interesting modular approach. So the types of like polynomial commitment schemes and other sort of like base level components, which we probably don't have time to dive into now, can all be swapped out depending on if new cryptography emerges or new methods emerge. And that just like basically says, to us at least, that like the sky is the limit. If you look at proving time and verification time of SNARKs as well, that's also been an exponential improvement. So we're very, very excited where things are going to go. And we haven't even really started pushing hardware to its limits either. SNARKs are highly parallelizable computations. They're embarrassingly parallelizable, which is a technical term, but also funny, which means that you can basically parallelize them as much as you possibly want to, and you won't have a slowdown in performance. So we are currently in a project implementing SNARKs on GPUs, which is very promising, and there will be ASICs coming down the pipeline. And so we think that like SNARKs are this technology right now that contain sort of like the fundamental key to solving a lot of these trust and decentralization problems. And it seems like they're just sort of like on the start of this hockey stick growth.
Yeah, you can see we're very excited about SNARK. So, yeah. And we are also, an ad here. We're working on our new construction exclusive new to Coda, so that will come out very soon. So we're very excited about that too.
I'll break the codename. We'll do another world premiere. Codename Pickles.
Actually, I think Isaac did a world premiere for it before. Anyway, sorry. too much SNARK excitement here.
All right.
So the last time I interviewed Izzy, I got the impression that Coda would be. This was very early on in the Coda project, and I got the impression that Coda would not have smart contracts, that in getting these recursive SNARKs in, you're going to need to sacrifice general computability. Is that constraint, does that still hold?
So one clarification of that. The reason that was sort of the initial plan was not because of any theoretical or technical limitations. It is perfectly feasible to have a recursive SNARK succinct blockchain and have full Turing-complete smart contract functionality. So this is a widespread misconception, but there is no theoretical limit or limitation on that ability. So it's very, very feasible. And initially, the reason why we weren't going with full smart contract functionality was just implementation time. We basically wanted to release something that would start providing value to people immediately and also prove out the idea that there could be a zk-SNARK succinct blockchain. And so we just wanted to get that out the door as quickly as possible, basically, and see what we could do with it.
But that is all changing. So the new SNARK construction we just talked about has a feature called Universal Trusted Setup, and that enables us to include full, general compute into the protocol. So how you'll see that at mainnet is that all the foundation for it will be there. We won't yet launch, and again, to Brad's point about wanting to launch in time, we won't have full SDKs and like an equivalent of a VM to write full smart contracts, but we will have, the kind of the essentials such as tokens and other predicates included in the protocol at mainnet launch, and then we'll soon follow with a full smart contract development kit.
Very cool. I think one thing while we're on the topic of SNARKs already, I think this other big movement in the Ethereum space is currently around these roll-ups, right, where you also use SNARKs to scale and basically increase the throughput. Is this also something that Coda is working on, that is deploying in to some extent, or how do you think about that?
It makes immediate sense for Ethereum because of all of its scalability challenges, right? Despite sharding and all of that. With us, the focus right now is to launch with the most decentralized and scalable blockchain. So hopefully, at base layer, we do not need certain such tricks like that for a certain type of scalability, which is more about throughput. We do, however, have ideas about how to improve latency and stuff like that. So we may look at layer 2 solutions who knows, maybe similar to ZK rollup. But although huge respect for the likes of Matter Labs and all the ones that are working on it, would think they're very cool and also kind of similar to Coda, but it doesn't solve the underlying issue with Ethereum and other chains in that the main chain is still huge. It's still a couple terabytes, right? And with Coda, that is the issue we're resolving right out of the gate.
Yeah. And yeah, sorry. I do want to say that it is really, really heartening and exciting to see kind of the community begin to coalesce around zk-SNARKs as one of the solutions, one of the most promising solutions to solve the scalability problems. Back when we started the project, summer of 2017 and beginning of 2018, people thought of zk-SNARKs only as a solution for privacy. So the fact that we're seeing so much broad-based adoption and excitement about using SNARKs for scalability, we are incredibly excited about that development. And just like everything else in the cryptocurrency space, we're sure the innovation of this open ecosystem is going to outpace what anyone would expect from a centralized group. So we're having fun sort of riding the wave along with everyone else.
So could you give us an imagination of how SNARKs could help Coda scale even further by having multiple blockchains or something like that?
It's less about multiple blockchains. It's more about, so if you look at Bitcoin, right, the simplest example, what limits throughput is block size. And the reason for that, again, is to keep the entire size of the blockchain small. What happens if you have a fixed size blockchain, right? You do not, block size doesn't become the main bottleneck anymore because you can increase block size without trading off decentralization. Yes, indeed, there's two main challenges that we face. One of them is the same as any other blockchain of just network bandwidth, right? In a true decentralized peer-to-peer network, it's not like just, I have 100 megabit per second, downstream, and I can, use all of that. It doesn't unfortunately work like that, but we're lucky to ride on the shoulders of other work done in the space, both on peer-to-peer messaging, gossip networks, and other stuff. And then the second one is more native to SNARKs, in that the cost and efficiency of SNARKs is already quite low. It's on the order of, to produce a SNARK proof, the cost is what, Brad, about a couple cents at most. Yeah. But to increase throughput to this magical hundreds, thousands of TPS levels, it still needs to come down a bit more. So, but then again, per what we discussed, because of this explosion, we have full faith that it's going to get there. It's just going to take a bit of time, but at least we can see that this is a sustainable path to increasing scale without having to do all these tricks about sharding or centralizing or master nodes and all the stuff that some of the other blockchains have to resort to.
Yeah, I think we're already quite far in, actually. We talked a lot about SNARKs and their implications because of all this excitement. I think we wanted to talk about a lot more stuff, but maybe we'll have to save that for another episode almost, I feel like. And maybe one thing that would be interesting to hear about. So Coda is already quite far, I'd say, in its testnet stages, and you are running this test competition, or basically like some challenges. Maybe you want to talk a little bit about that. How is that progressing, and where are you at right now?
Yeah, so I guess the big news item is we recently launched Genesis. And Genesis is basically our program to try and decentralize the ecosystem before we launch. So with any respectable cryptocurrency, you need to have a very broad base of people who are operating as professional or sort of amateur block producers. So in the early days of Bitcoin, it was folks who were on the cypherpunk mailing list and they ran nodes in their basement. We kind of want to restart a similar ethos for Coda. And so we launched a program where we are giving basically pretty sizable Coda grants to folks who can show that they are excellent validators and they are committed to the ecosystem for a significant period of time. So we basically are giving grants of Coda, and if you stake with Coda for a year after the mainnet launch, you will receive the grant on sort of like a vesting schedule. So this is a way to get basically, one, involve a lot of people in the ecosystem who might not have access to a ton of capital. Like most cryptocurrencies, they've been launching with like big ICOs or something like that. We want to give an opportunity for people to be involved just through their labor and their interest. So that's a big component of it to us. And also, we want the networks to be really decentralized because we think that decentralization is incredibly important for security. So we launched the program, and so far we've had over 1,100 signups just in the few days since we launched it. We've had 300 people express interest in staking on the testnet, which was like a 10 times improvement over what we had previously. And we have a really vibrant community forming right now of folks who are interested in technology, interested in becoming professional block producers, or amateurs who just like want to try out and experiment with the latest technology. So
I also want to add, like, we've been asking the question of why, even before Genesis, before we had any sort of incentivization around, we saw a very decent and healthy amount of interest, more, same if not more than some of the other comparable projects. And we were wondering, like, this is great, but why, what's the root cause? And the root cause is that running a Coda node, per our discussion, is just way easier than some of the other networks. So that's why, like, certain people, if they were disheartened in other networks by, how much of a complicated machine they have to run, or uptime requirements, or even the basic fact that most proof-of-stake networks are limited to 100 or so validators, whereas the consensus mechanism that we use, called Ouroboros, has an unlimited validator set. So this allows anyone to become a validator. You don't need to compete and have a professional operation running in order to be able to have that privilege. There is, again, the key word we think for Coda is permissionlessness, and that means no one has to be in a privileged position to partake in the network.
That's it, Felix?
Yeah, for sure. I mean, like we said, I just remembered also that we were gonna talk about the roles. I guess we didn't even do that, but one thing that probably is also there, right? The snarker role itself is also permissionless, and everyone can do that. So that's probably also another reason why, it's very easy to get engaged with Coda. So I'd recommend anyone that listens to this and wants to try it out, please do so. Maybe you guys want to talk a bit about where people can learn more.
Yeah, codaprotocol.com. That is CODA protocol.com.
and our Discord.
And our Discord,
our Discord is bustling with an amazing technical community. It's definitely not like some of the other Telegram groups, especially of other projects. There is a lot of community contribution. One other thing I'd add about Genesis is not the way to become a Genesis member is not by validating or becoming a good validator. That certainly is a big portion. But like if you're a super active community member, helping with community engagement, events, translations, and all that sort of stuff, then those are also amazing qualifications to make you eligible for the program. So yeah, come in on to the Discord, check out what's happening, meet other community leads that are, again, not our employees. They're just there because they love the project. And codaprotocol.com.
Or codaprotocol.com/Genesis if you're interested in the Genesis.
There's a lot
program.
of links.
Yeah.
All right. Yeah, we'll definitely also put these links in the show notes. And then, thank you guys so much for coming on and teaching us more about SNARKs. Was a great conversation.
Yeah, our pleasure.
Thank you guys. It was a pleasure being on.
Thank you for listening to the Chorus One podcast. Visit chorus.one for more information about our work. Don't forget to subscribe to the podcast to stay tuned on new episodes airing every Monday.